Hey folks, Dr. Tom McNamara here again for our course in trigonometry. In this video we are going to continue working on examples of solving right triangles, but we're going to look at some different variety here. Now remember, of course, solving a right triangle means determining all the side lengths and all the angles. Okay, let's look at this example right here. Suppose that we have this situation here, okay? We got a circle here. We got kind of a line of sight to the edge of the circle, and we got a line of sight going to the center of the circle. We want to know how big that circle is. Oh no, actually we know how big that circle is. We want to know how far away the circle is. Okay, now you might say, well, this is dumb. When would you ever do this? Okay, well, think of a big circular thing that's really far away and we can't measure the distance directly. Well, this allows us to measure it indirectly. Big circular thing that's really far away, like maybe a star or a planet. Okay, what you can do is you measure the angle between looking directly at the center of the object and looking at the edge of the object. What's that angle? That's how you can tell this. And if we know how big the object is, we can tell how far away it is. And vice versa, if we know how far away it is, we can tell how big it is. So a lot of applications to this trigonometry to indirect measurement. So this is kind of a skeleton example of something like that. Okay, so in this example, they tell us that the circle is radius 12. That means this is 12 and this is 12. They want us to find x. All right, well, I'm interested in the hypotenuse. X is part of the hypotenuse. The hypotenuse is x plus 12. Okay, so I know that if I take, I used sine a lot last time. I'm going to use sine again because I got the opposite, and I want to say something about the hypotenuse. So sine of angle A would be opposite over hypotenuse. So it's this side length right here over 12 plus x. And in fact, I can say even more. They tell me that angle A is 31 degrees. So now I need to solve for x. Okay, now whenever you got an equation with fractions, you can clear out denominators. Multiply both sides by your denominator. That'll give you a new equation without the fractions anymore. So multiply both sides by 12 plus x. Okay, so if this equation up here is true, then this equation is true. I want to get x by itself. A couple of ways to do it. Here's what I'll do. I'll do this. Okay, well, what did I do here? Well, I want x by itself. Let me get rid of this sine 31 by dividing it out. Okay, so I'm dividing out. Divide this side by sine 31, it cancels. Divide that side by sine 31, you got 12 over sine 31. Now notice, if I cancel out the sine 31, I got x plus 12. I want to get rid of that plus 12, I subtract 12. So now we're down here. Okay. Now once we've got this, we can use our calculator to do the computation. Okay, so 12 divided by 31 sine equals minus 12. So I am getting, well, two significant figures on all these, so I'm getting 11. So x equals 11 in this example. Okay, so using the principles that we discussed in that video that we just saw, the one on solving right triangles, I want to know something about a side length. I incorporate a trig ratio that involves that side length that I'm interested in finding out things about and a known side length. In this case, I knew that side, I knew the opposite side to angle A. I want something about the hypotenuse. If I know the opposite and want the hypotenuse, I got to use a trig ratio that involves opposite and a hypotenuse. So that's why we're bringing in the sine function. Okay, I want to do one more example kind of like this. Well, not kind of like this, but one more example where we use the principles for solving a right triangle. Okay, let me bring in this picture right here. So it's kind of going to be a triangle within a triangle. Okay, so we're given that this is 32 degrees. Okay, we're given that this is 48 degrees. That's a 17 and that's a 12. And the problem is asking us to find this and this. Okay, we'll look at an application of this in the next video. Okay, but let's just kind of treat this as a pure mathematical exercise right here. All right, so let's start by finding this. Start by finding the side length y. Okay, we've got a right triangle here. I know the hypotenuse, I want the adjacent. So I'm going to bring in the cosine function, right? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse. So I know cosine 48 degrees equals y over a known side length of 12. So I can get y by taking 12 times cosine 48 degrees, right? We're solving for y. Over on the right side, we got y divided by 12. We want to clear out that divisor, so we multiply. Okay, we can break out our calculator here, and I'm going to round it to two significant figures. Two significant figures on everything, so our answer should have two significant figures. Okay, 48 cosine times 12. Okay, so 8. Okay, so y equals 8. Okay, now we want to find x. Okay, well, I'm looking at the, now, be careful here. We don't really think about this triangle. Okay, that's not a right triangle. The principles that we've been discussing so far apply only to right triangles. Okay, so we're going to find x. Now, that side is adjacent to the 32 degree angle, so once again we're going to bring in cosine. It's cosine 32 degrees equals the adjacent side over the hypotenuse. Okay, the 32 degree angle is part of this outside triangle that has a hypotenuse of 17. Now, the adjacent side is actually x plus 8. Okay, where's the 8 coming from? Well, it's coming from what we just found. Okay, the triangle I'm talking about, and maybe I'll highlight it here in the orange, is this guy right here. We've got to use right triangles if we're going to apply the principles that we've been discussing so far. So the adjacent side, well, x is not the length of the adjacent side, it's only part of that length. Here's the rest of it, and we just figured out that was 8. All right, easy enough to work out. Multiply over the 17, subtract away the 8. 17 times cosine 32 degrees minus 8. Okay, knock that out on your calculator. 32 times cosine of that, so hit in the 32, take the cosine, multiply by the 17, subtract the 8. I'm getting 6.4 to two significant figures. Okay, so two problems that use the principles of solving right triangles that we discussed in the previous video. In our next video, we're going to start to do more applications of this stuff to more realistic situations. Okay, great.